Hello everyone. In this video we will use the concept of the derivatives to calculate the maximum and the minimum value of the various function. This video covers the definition of local maxima and the local minima, definition of absolute maxima and the absolute minima, turning point or critical point, point of inflection, first derivative test to find the maxima and minima, second derivative test to find the maxima minima, and the use of the animation. So let's begin. Let's see the definition of the maximum value. A function f is said to have a maximum value in interval I if there exists a point c such that fc is greater than fx for all x belong to I, and the point c is called the point of maximum. Now see the graph of the function y is equal to minus x square. Now see the graph. Take the interval minus 20 to 20 and suppose this point is c. Therefore the fc is always greater than fx. X belong to this interval minus 20 to 20. Here c is equal to 0. Therefore f0 is always greater than fx, where x belong to the interval minus 20 to 20. Therefore the point c is equal to 0 is called point of maxima. And the maximum value of the function we get after putting the value of 0 in the function, f0 is equal to minus 0 square, which is equal to 0. So the maximum value of the function is 0 at the point 0. Let's see the definition of minimum value. A function f is said to have a minimum value in the interval I if there exists a point c such that fc is less than fx for all x belong to I, and the point c is called point of minimum. See the graph y is equal to x square and we take the interval minus 20 to 20 in this interval, and suppose this point is c. Therefore the fc is less than fx for all x belong to this interval minus 20 to 20. Here c is equal to the 0. Therefore f0 is always less than fx. Therefore the 0 is called the point of minima and f0 is called the minimum value of this function, which is equal to the 0. We often come across the word local maxima minima and the absolute maxima minima. Let us see the definition too. So the local maxima is a point of a function with highest output locally. A function fx is said to have a local maximum at x is equal to a if the value of fa is the greatest than all the value of fx in the small neighborhood of the x is equal to a. Now suppose this point is a and this point is b, then the bracket very close to the point a and the point b represent the neighboring point of the a and b. Then we can easily see that the value of fa is always greater than the neighboring point of a. Similar in the case of b, fb is always greater to the fx, where x is the neighboring point of b. Therefore these 2 points a and b are said to be the local maximum. Now similar to the local minima is a point of a function with lowest output locally. A function fx is said to have a local minimum at x is equal to a if the value of the function at x is equal to a is less than the value of the function at the neighboring point of x is equal to a. Now suppose this point is b. Therefore the bracket around the b represents the neighboring point of the b. We can easily see that the value of fb is less than the value of fx, the neighborhood point of the b. So here fb is less than fx. Therefore the point b is called point of local minima. Here the absolute or the global maxima minima represent either the highest possible output of the function or the lowest possible output. Now let us suppose that this point is a, this point is b, and this point is c. Therefore, all 3 points A, B and C are the point of local maxima. But the value of the function at the point B is the highest value of the function in the domain of the function. Therefore, the B is called the point of global maxima or the absolute point of maxima. Because the value of the function at the B is greater than Fa, this Fb is also greater than Fc. Similarly, let's suppose that this point is x1, this point is x2 and this point is x3. So all 3 points x1, x2 and x3 are the point of local minima. But the value of the function at the point x2 is the lowest value in the domain of the function. That is fx2 is less than fx1. fx2 is also less than fx3. Therefore, the point x2 is called the global minimum or the absolute point of minimum. Now see the turning point or the critical point. The turning points are the points on the curve where the behavior of the curve changes. Means if the function is decreasing from a particular point, then after that point if the function is increasing or vice versa. And at the turning point, the tangent at the turning point is always parallel to the x-axis. At turning point, the slope of the tangent would be 0. Therefore, the slope at this point dy by dx would be 0. Also, the dy by dx at this point would be 0. And the dy by dx at here we can see the tangent at the point of minima is parallel to the x-axis. Point of inflection is the point on the curve where the behavior of the curve does not change. Point of inflection is a critical point where before the point the function is increasing and after the point function is also increasing. Here we can see the before the point 0 and after the point 0 the function is increasing. So the 0 is the point of inflection. Now the method of finding point of maxima and the minima. There are two methods to find the maxima and minima. First is by the first derivative method. And the second is second derivative method. Now let's see the first derivative method. Let y be any y is equal to fx be any function defined in the interval I. Then first find the derivative of this function and equating 0. Solving this equation f dash x is equal to 0, we get the critical points. Suppose these are the x1, x2, x3 and x4. In the second step, divide the real number line in subintervals at the point x1, x2, x3 and x4 like that. In third step, we check the sign of f dash x before the point x1. Suppose this sign is positive and after the point x1 the sign of f dash x is negative. And suppose after the point x2 the sign of f dash x is positive and after the point x3 the sign of f dash x is negative and after the point x4 the sign of f dash x is positive, like that, plus minus plus minus plus. Since the sign of f dash x changes from plus to minus at the point x1, therefore the x1 is said to be the point of maxima. And the sign of f dash x changes from minus to plus at the point x2, therefore the point x2 is called the point of minima. is called the point of minima. Also, the sign of f dash x changes from plus to minus at the point of x3. Therefore, the point x3 is also called the point of maxima. Therefore, the point x1 and x3, these 2 points are the point of maxima, and the point x2 and x4 are called the point of minima. Now see the one example. Here we can see the slope of the tangent at the point of maxima and the minima are parallel to the x-axis. And when the curve is increasing, the slope is positive, that is the f dash is positive. And when the function is decreasing, the slope of tangent is negative, that is the f dash x is negative. To find the local maxima and the minima by the first derivative method, the example is fx is equal to x cube minus 3x plus 3. So we have to find the local maxima and the local minima. So for this, first step we differentiate this function, given function. So we get 3x square minus 3, which is equal to 3 into x square minus 1, are equal to 3 into x minus 1 into x plus 1. Now equating f dash x is equal to 0, we get x minus 1 or x plus 1 is equal to 0. Therefore, x minus the 1 0 or x plus 1 0, we get x is equal to 1 or x is equal to minus 1. In the second step, divide the real number line at the point minus 1 and 1, like that. Now check the sign of f dash x is equal to 3 into x minus 1, x plus 1 before the point minus 1. So we put simply minus 2. So we put x is equal to minus 2, we get 3 into minus 2 minus 1 to minus 2 plus 1. 3 into minus 3 into minus 1 is equal to 3 into plus 3. Finally, we get the 9, which is positive. So the sign of in the interval minus infinity to minus 1 is plus. This is positive. To check the sign of f dash x in the interval minus 1 to 1, we take the x is equal to 0. Therefore, f dash 0 is equal to 3 into 0 minus 1 into 0 plus 1. We get 3 into minus 1 into plus 1 is equal to minus 3, which is negative. So the sign of f dash x in this interval minus is minus. To check the sign of f dash x in the interval 1 to plus infinity, we take the x is equal to 2. Therefore, f dash 2 is equal to 3 into 2 minus 1 into 2 plus 1 equal to 3 into 1 into 3 is equal to plus 9, which is positive. Therefore, the sign in this interval is positive. We can easily see that at the point minus 1, the sign of f dash x changes from plus to minus. Therefore, this point 1 is point of maxima. And at the point x is equal to 1, the sign of f dash x is changes from minus to plus. Therefore, the point 1 would be point of minima. Therefore, the maximum value of the function we get at the point x is equal to minus 1. Therefore, the maximum value of the function f max we get at the point x is equal to minus 1, which is equal to minus 1. Putting the value of x is equal to minus in the given function, minus 1 cube minus 3 into minus 1 plus 3. After simplify we get minus 1 plus 3 plus 3. So finally we get 5. And the minimum value of the function we can get at the point x is equal to 1. Therefore the minimum value of the function we get at the point x is equal to 1. So f1 is equal to 1 cube minus 3 into 1 plus 3. This 3 is cancelled out, we get 1. So the maximum value of the function is 5 and the minimum value of the function is 1. Now see the another example of the function 2x cube minus 6x square plus 6x plus 5. We have to find out the local maxima and the local minima. So similarly we start from the step 1. We differentiate this function f dash x is equal to 6x square minus 12x plus 6. Now equating 0, f dash x equating 0, we get 6x square minus 12x plus 6 is equal to 0. So we get the 6 take outside, so we get x square minus 2x plus 1 is equal to 0. This can be written as 6 into x minus 1 whole square is equal to 0. So equating 0 we get x is equal to 1. So 1 is the one is the critical point. Now take the second step. We divide the real number line at the point 1 and check the sign of f dash x before 1 and the after 1. Before 1 if we take 0, therefore f dash 0 is equal to 6 into 0 minus 1 whole square is equal to 6, which is positive. And after the 1 if we take the 2, so the f dash 2 is equal to 6 into 2 minus 1 whole square is equal to 6, which is also positive. Therefore at the point 1 the sign of f dash x doesn't change, so this point 1 is called the point of inflection. Now see the second derivative method to find the local maxima and the minima. Now suppose y is equal to fx. Now see the second derivative method to find the local maxima and minima. Now suppose y is equal to fx be any function which is defined in the interval I and is twice differentiable. Then in the first step we find the f dash x and equating 0. Suppose we get x1, x2 and x3 like that. These points are the critical points. In the second step we find the second derivative of the function f double dash x and check the sign of f double dash x at the point x1, x2 and x3. Now suppose the sign of f double dash x at the point x1 is negative, then the point x1 is called the point of maxima. And if the sign of f double dash x at the point x2 is positive, then the point x2 is called the point of minima. So take the function fx is equal to 3x power 4 plus 4x cube minus 12x square plus 12. Now in the first step we differentiate this function. So we get f dash x is equal to 12x cube plus 12x square minus 24x, which is equal to 12x within bracket x minus 1 into x plus 2. Now equating f dash x is equal to 0, we get 12x into x minus 1 into x plus 2 is equal to 0. So we get x is equal to 0 or x is equal to 1 or x is equal to minus 2. Now again differentiate the equation 1. We get f double dash x is equal to 36x square plus 24x minus 24, which is equal to 12 into 3x square plus 2x minus 2. Now check the sign of f double dash x at the point x is equal to 0. So we put x is equal to 0 in this f double dash x, means f double dash 0 is equal to 12 into 0 plus 0 minus 2, which is equal to minus 24, which is negative. Therefore 0 would be the point of maxima. Now check the sign of f double dash x at the point x is equal to 1. Therefore f double dash 1 is equal to 12 into 3 into 1 square plus 2 into 1 minus 2, which is equal to 12 into 3 is equal to 36, which is positive. Therefore the point x is equal to 1 is the point of minima. And the sign of f double dash at the point x is equal to minus 2 is equal to 12 into 3 minus 2 square plus 2 into minus 2 minus 2, which is equal to 72, which is positive. Therefore minus 2 is also point of minima. Since 0 is the local point of local maxima, therefore the maximum value of the function we get after putting the value of x equal to 0 in the given function. f0 we get 0 plus 0 minus 0 plus 12. So this is 12. And the point of local minima we get at the point x is equal to 1. So if we put x is equal to 1, we get, therefore f1 is equal to 7 and f minus 2 is equal to 20. Therefore the 7 and 20 are the 7 and minus 20 are the local minimum value of the function respectively. So this was all about the concept of the maxima minima. In the next video we will do some more example and we do the exercise 6.5. Thank you.